as we continue our discussion of trigonometric functions, we need to take a look at one more group of trigonometric functions and their graphs. And those are the inverses of the trigonometric functions. Now, when we studied cosine and sine, we know that the typical period was 2 pi. We know they bounced between -1 and 1 for the range. That was the same for both of these. And for tangent, that was the one that was different. They only had a period of pi, and the graphs took off, so there was no limits to the range. Now we're going to take a look at their inverses. Now, this button is built into most calculators. This is the inverse trig function, the inverse of cosine, the inverse of sine, and the inverse of tangent. And the reason I put the original functions up here is I wanted you to notice something about their inverses. Notice where the domain has moved to the range, and what the range has moved to the domain. So they have switched places, which makes sense for an inverse. And this little -1 is how you say inverse of cosine or inverse of sine. Now, if we look at the graphs, this says the domain stays between -1 and 1, which is true, and the range goes from 0 to 2 pi. So it looks a lot like that cosine curve kind of turned on its side. The sine curve looks a little like a sine curve, bouncing between -1 and 1, and having this go to 2 pi. And of course, tangent always being a little different, and depends on how you graph it. But if you graph it from -pi/2 to +pi/2, it would look something like this. If you graph from 0 to pi, it would look something like this, but it has one going one way and one going the other, and the asymptotes are now horizontal instead of vertical. So that's what these inverse trig functions look like. How are we going to use them? Well, if we're talking in degrees, and they say something like the inverse cosine of 1/2, I'm going to go to my unit circle, because 1/2 is something that's on my unit circle, and I'm going to try to figure out where cosine is equal to 1/2. Now, on my unit circle, the first time I see a cosine of 1/2 is at 60 degrees. The problem is there's another one. So I keep going around and I see another cosine of 1/2 at 300 degrees. That's great if I have my unit circle, which we will, but if I don't have my unit circle and I want to use a calculator, the calculator has to make a choice. Now, if I wanted to do an inverse sine of 1/2, so now I'm looking for where the sine is equal to 1/2. So I go to my unit circle, and the first one I find is at 30 degrees, but I also find one at 330 degrees. For tangent, I'm looking for an angle that has tangent of 1. And the only way tangent can be 1 is if sine and cosine are the same. So I'm looking for sine and cosine to be the same. That way I get a +1, and there are two of them. The first one shows up at 45 degrees. The second one shows up not at 135, but at 225, where they are both negative, and they cancel out to give me a +1. Now I can do the same thing in radians. It doesn't matter, I'm still using my unit circle. So I'm looking for a cosine value that's -√2/2. So I'm not going to find one in the first quadrant, but I am going to find one in the second quadrant. It shows up at 3 pi/4, but there is another one. It's down in the third quadrant. It's at 5 pi/4. If you switch your calculator to radians, or if you graph something on a graphing calculator in radians, that's the spot where you're going to find this. If I'm in radians and looking at sine of 0 happens at 0 pi and at 1 pi, so it also happens at two places. And then this one can be kind of confusing. In order to get this, I have to have a 1/2 on top, a √3/2 on the bottom, but one of them has to be negative. So I'm looking for those two numbers. This is my sine value, this is my cosine value, but one of them has to be negative. So the first place I see this, where one is negative and one is positive, is at 2 pi over 3. Excuse me, 5 pi over 6, I misspoke. So 5 pi over 6 is the first one. The next one's going to be over in the fourth quadrant, and it looks like it's at 11 pi over 6. Now, this is great if I have things that are on my unit circle. But let's take a look at some examples where we don't have a unit circle, so we're going to need a calculator to do some of these calculations. So now I don't have my unit circle, I'm using my calculator, and I have already put it into radians, and we're going to tackle this first problem here. So you hit the second key to get that inverse sine function. Negative 0.9 I don't recognize. It's not something that I'm used to seeing on my unit circle. So I punch it into my calculator, and I'm just going to keep a couple of decimals. I get negative 1.12 radians. Now here's the problem. That's not on my unit circle. It's not between 0 and 2 pi, what we're used to dealing with. So I'm going to make an adjustment to this, and I'm going to add 2 pi to it. That's one revolution around my unit circle. So if I add that on, I'm now sitting at 5.16. So that value shows up at 5.16 radians. Now I could keep doing that. I could keep adding 2 pi or subtracting 2 pi and find lots of answers to this, lots of angles that work. What we're going to do to simplify that is we're going to do this. That's going to cover all of those other ones that show up. Now, sine only, it doesn't only work at that angle. I'd also get an angle of 4.26. It also works. Now this is the trouble I was talking about earlier. Our calculators only give us one answer. But if you take the sine of 5.16 and the sine of 4.26, you actually get the same answer. So this has two possibilities. For our purposes, we're going to only worry about the principal value that our calculator gives us and give this answer right here, even though there is another possibility for this particular sine function. So the process is pretty straightforward. I'm going to do the inverse sine of 0.44, and my calculator gives me 0.46 if I round it to 2 decimal places. I don't have to adjust that one. It's on my unit circle. It's between 0 and 2 pi, but I am going to tack this on to get all the possibilities. Tangent, cosine work the same way. I'm going to do the inverse tangent of negative 0.84, and my radian answer, I get negative 0.70. I'm going to adjust this one, so I'm going to add 2 pi to it. I get 5.58, but I'm not going to add this 2 pi n at the end because tangent has a smaller period. So I don't need the 2, I just need the pi n, and that covers all my tangent values. Now the other thing we can do here is we can do some basic solving with these trig functions. It solves just like any other variable. I combine like terms, so I'm going to move this cosine to the other side, and I'm trying to get theta by itself. So I have to add 1 to both sides. I have to divide by 3 on both sides, and I get to this point right here. This is where I use my inverse trig function. So theta is going to end up being the inverse of cosine of 1/3. And since I don't recognize that one, I'll use my calculator to do the inverse cosine of 1/3, and it says it's 1.23. If they tell me all of them, I add that 2 pi n onto the end of it. But a lot of the questions will throw this in here, and it throws students off, but it shouldn't. All that means is stay on your unit circle. I don't need to add all the other possibilities. It only wants the main ones. We're going to focus on the one that the calculator gives us, the principal value. There it is, 1.23 radians. Now, everything we do with solving comes into play. Factoring, multiplying, things like that. I see signs in common here, so I'm going to factor them out. I have two things that multiply to give me 0, so I'm going to set both of those equal to 0 and solve them individually. Now this one's almost done. Theta is equal to the inverse sine of 0. That one seems familiar. 0 is something that's on my unit circle. We actually did this earlier. If I have my unit circle handy, I'll use it. If I don't, I can use the calculator. But sine is 0 at what angle? At 0 pi and at 1 pi. Now the other one, a couple extra steps. Divide by 2 on both sides, and I've got a cosine function, so I'm looking for an angle that has a cosine value of -1/2. And I would definitely pull out my unit circle. If it was something that I'm not as familiar with, I can type in my calculator, but this shows up at 2 pi over 3 and at 4 pi over 3. There's the two answers for this half and the two answers for that half, so overall those are my 4 answers. And I don't have any domain issues because everything is cosines and sines, cosines in the previous problem. So we can do basic solving using these inverse trig functions.